IP addresses are broken into classes. Common classes are Class A, Class B, and Class C. While there is a Class D address space that's used for multicast, and a Class E address space is used for research. So we won't reference those in this video. Class A addresses are decimal values 1 through 126. This would mean that the very first octet is going to have a binary value that begins with a 0. A Class B address space is 128 to 191. This means that the first octet binary value is always going to begin with 10. In a Class C address space, the first octet decimal value is 192 through 223. This would mean that the first octet binary value is always going to be 110. The remainder bits can be set to pretty much anything. The only differentiator is in a Class A address space, where the 127 address is a reserved address and not counted as part of the Class A address space. In a Class A, the first octet indicates the network address. In a Class B address space, the first 2 octets indicate the network ID. And in a Class C address space, the first 3 octets indicate the network ID. For example, in a Class A address space with an IP address of 10.1.2.3, the first octet, which has the identifying value of 10, would be the network. In a Class B address space with the address 172.17.2.3, 172.17 would be the network. And in a Class C address space, the first 3 octets, 209.165.202, would be network address. This leaves the last octet, which is 130 in that Class C address space, as being the host address. In the Class B address space, in our example, the 2.3 would be the host. And in a Class A address space, as with our example, the 1.2.3 portion would be the host. The formula to calculate the number of hosts available is 2 to the n minus 2, where the n is the number of bits in the host portion of the address. So, applying that formula, we have 16,777,214 hosts when you have 24 bits remaining. Now, with a Class B, we do 2 to the n minus 2. We end up with 65,534 hosts per network. And with a Class C, we do 2 to the n minus 2, and we end up with 254 hosts per network. Now, if you're wondering why we are subtracting these 2 addresses, it's because we have to account for 2 reserved addresses, the network address, which is the first, and the broadcast address, which is the last in each of these ranges. Class A, B, and C addresses have default subnet masks. The default subnet mask for a Class A address is a /8, or 255.0.0.0. A Class B default mask would be 255.255.0.0, or represented as a /16. And a Class C address space would be represented with a 255.255.255.0 default mask, or it could also be represented as a /24.